Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at using transformations of functions on our typical parent or library functions to create a new graph. So using the parent function f of x equals the square root of x, a portion of which is shown down here, we want to graph g of x equals the square root of 2 times x plus 4, and we want to describe the transformations that occur. So I've got two transformations happening here, and both of them are on the inside. So I'm going to use my acronym IHOD or IHOD that says transformations on the inside affect the graph horizontally. They do the opposite of what they look like, and they affect the domain or the x values. So a 2 multiplier, I know that multipliers make compressions or expansions. So this is going to be a horizontal. Well, let's see. When I multiply by 2, I normally think of it getting bigger. So if this is opposite, this is actually going to get smaller or be a compression. So that's going to be a horizontal compression by 2. And then my plus 4 on the inside, I know that plus transformations make shifts. So this is going to be a horizontal shift. And it does the opposite. So normally plus would make me think go to the right, but opposite of that is going to be left 4. So this is going to be a horizontal shift left 4. Now when I go to work with these, remember that we need to do order of operations. So I here have a multiply and an add. So I'm going to need to do the multiply one first. Taking some of my common points here, we have 0, 0, 1, 1, and 4, 2 fitting on our graph. So if I take a horizontal compression, thinking of doing the opposite of what it looks like, I'm actually going to divide each of my x values by 2, or make them half as far away from the x-axis, or sorry, the y-axis as they are. So 0, 0, taking 0 and dividing by 2, that's still 0. So my 0, 0 point is not moving. 1, 1, taking 1 and halving it or dividing it by 2, now I'm going to be at 1/2 1. So again, I've taken the distance from the y-axis and I have halved it. 4, 2, taking 4 and dividing it in half, now I'm at 2, 2. And although it didn't fit on our previous one, if you really think about it, the next one would be 9, 3, since the square root of 9 is 3. This one will now fit if we want to go ahead and include it. Half of 9 is 4.5 or 4.5, so 4.53 will also now fit on our graph. So there are my points with my horizontal compression by 2. Now I'm going to go ahead and take those and shift each of them to the left by 4. So shifting to the left, I'm going to take each of these points and just count 4 left. So 1, 2, 3, 4. Here. 1, 2, 3, 4. So I'm halfway in the middle here. 1, 2, 3, 4. And 1, 2, 3, 4. All right, connecting those using that same curved shape, I would have something that looks about like that for my graph of g of x. All right, guys, that does it for this video on transformations of functions. We'll see you in a future one.